Where can automatic or digital computers actually be found? Well, it may surprise you to know, to discover and be told that 98% of the microprocessors that are currently developed in the world, so these are microprocessors, so these are small scale computing devices, 98% of those are used in systems which are embedded inside other devices. So 98% of these are used in systems that are embedded inside other devices. This term embedded system is what we're kind of referring to there. Therefore, leaving only about 2% that are used in traditional desktop machines, which, you know, is surprising for some, because desktop machines are clearly a lot more visible to people than these embedded systems. But we'll have a look at where these embedded systems can be found in a second. So if we're looking at microprocessors, there's another key term there. There's a slightly different version of a microprocessor, which is called a microcontroller. It's certainly worth looking at that, because these embedded systems, not exclusively, but tends to be microcontrollers. Microcontrollers are a very special type of microprocessor, which contain 4 main components. Okay, so this is a microcontroller that I've drawn a diagram of here. So let's just put that on there. Microcontroller. Okay, so a microcontroller contains 4 main components. The first one is a central processing unit, or a CPU. So a CPU, I'll repeat that again, a central processing unit, and I'll do another video about central processing units, so don't worry too much about how that works at this stage. It's also got an area of read-only memory, or ROM, and ROM is where the programs are stored for the microcontroller to execute the code, if you like. There's also a section of random access memory, or RAM, and RAM is the working store for holding data. And finally, some sort of input-output interface. Okay, so lots of abbreviations there, but I'll just quickly go through them again. CPU, central processing unit; ROM, read-only memory where the programs are stored; RAM, which is the working memory that the computer needs whilst the microcontroller needs whilst it's working; and also some kind of input-output interface so that it can interface with the analog world. Okay, right. Let's take a look at what that might look like in practice. Well, if you've ever seen a microcontroller, you might know this is the first ever commercially developed microcontroller. It's called the TMS 1000, and it was the TMS 1000, and it was made in 1974, which isn't really that long ago. Okay, basically takes inputs from the analog world through switches, maybe. So switches or sensors, or maybe buttons. Okay, and processes and stores data in some way, digital data. So the process and storage go on in here, and finally, hopefully, generates some useful output. So that could either be sound, or it could be some sort of display of some description, or it could even be some sort of movement if it were to control some sort of actuator. So these things haven't been around for a massive amount of time, but they occur in lots and lots and lots and lots and lots of places. It's estimated that, in fact, in a normal house, you know, what is a normal house, but you kind of get the idea. In a normal house, there are round about I'm going to draw these, just bear with me a minute. There are around about 4 microprocessors. Okay, so 4 devices with microprocessors in them. And those 4 devices may well be... Why is the number 4 not appearing on there? That's very interesting. Is it not? There we are, we're back again. 4 devices with microprocessors in them. However, there are estimated to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, tedious, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Round about 36 devices in a modern home. Right, I ain't going to draw lines to all of those. 36 devices in a modern home that contain microcontrollers. All right, so this is, basically not the desktop machines. There's a massive amount more of microcontrollers in the sort of, average house, whatever the average house is. So, where do we find these things? Let's have a look at some various different things. So I've got some pictures of things which you may find in a house, and the competition, it's not really a competition because there's no prize, but the question is, I want you to think about for a second, which one of these devices you might find a microcontroller in. Bear in mind that we're not talking about desktop computers here, we're talking about microcontrollers, which are computers embedded systems inside other devices. So remember, these are actually referred to as embedded microcontrollers. Where are they? Have a think. Pause the video if you need to. Controllers. Pause the video if you need to. Okay, and we're back. This is meant to be an answering machine. I think that has got a microcontroller in it. This is a remote control for some sort of TV or other. Yes, indeed, has a microcontroller. Some sort of audio desk. That's definitely got a microcontroller in it. Camera. Absolutely, 100%. Some sort of aged MP3 player that nobody uses anymore. Absolutely, 100% got a microcontroller. A pirate. No microcontrollers in a pirate, unless it's some sort of robotic pirate. I suppose it could be. How about a desktop printer? Absolutely, 100% in there. A calculator, certainly from the very early days of calculators, they all had microcontroller chips in them. An alarm clock? Absolutely. Dishwasher? Totally. Racing car? Any old car? Absolutely. Stuffed with them. I've got a friend who works for Bentleys, and he's a seat designer for Bentleys. He works in the electronics, and there's something ridiculous like 12 computer systems in a Bentley seat. I mean, absolutely rammed with it. Not as rammed as aircraft are with microcontrollers, however. A glass of champagne? No microcontrollers in glass, unless you drop one in it, of course, but no microcontrollers in a glass of champagne. A robot? I should say so. Traffic lights? Totally. Even in the traffic lights, but certainly in the control systems. What's that? A Christmas tree? Yeah, if you've got one of them flashing light sets that has got little patterns in it and everything that changes, microcontroller in there. Hard disk drive, so a component inside a desktop computer system. Yes, microcontroller in that. A glass of beer? No, not in a glass of beer. Okay. What else have we got here? A microwave oven? Absolutely, 100%. Some sort of fruit machine? Definitely in a fruit machine. This is an embedded medical device right there. Definitely got it in. We're left with 2 things. A stapler. Oh, what about the rocket? My goodness, stuffed with microcontrollers in a rocket. Famously, an error in the programming in the Ariane 5 rocket caused it to crash catastrophically. So yes, definitely microcontrollers and computer systems in there. A stapler? Not in a stapler, definitely not. And absolutely 100% not in a desktop computer system. This is the one that I think you probably need to be most aware of, that microcontrollers are not embedded in traditional computer systems, but they are embedded in all these other different devices over there. Okay, so let's think about embedded systems themselves and what the advantages and disadvantages of these things are. So I'm just going to think about, first of all, the good stuff. So we'll go with the good stuff first of all. The good stuff about microcontrollers, right, they're dead efficient. They only really need to do one job. So they're super efficient, hyper efficient. They also use very little power as well. Some microcontrollers use in the nanowatts of power when they're asleep, which is, you know, basically nothing. But they can wake up as well. They generally have low complexity, so they're not very complex devices. And that means that the cost of production can be cheap as well, so they're cheap to mass produce. And you know, microcontrollers produce computers on chip, really, and they're generally very small as well, portable, small, discrete, whatever. Let's think about the bad stuff. So what's bad about microcontrollers and embedded systems? Right, okay, well, inherently, because they're very simple systems, they're actually quite difficult to write programs for. Difficult to write programs for. I couldn't just pick up a microcontroller and chuck a program onto it like I might do onto a desktop machine. They actually can be hard to reprogram as well. Once you've programmed a microcontroller or an embedded system, it's sometimes difficult to change the program that's on there. You may have heard of the term flashing firmware. That's basically what you're doing with it. With that is inside the microcontroller, you're changing the program that runs. They have limited power. They can't really do a lot of stuff. Limited power, because that's kind of the advantage of them, is that they do one job and do it pretty well. And they're also, you know, because they're only doing one job, they're pretty inflexible. Although some people have managed to, you know, squeeze out some quite interesting performance from certain microcontrollers, but generally you'd have to use some add-on sort of device to make the microcontroller do something slightly differently. Not only that, actually the architecture of microcontrollers is considerably more different than standard desktop machines. Now, there's a term there that I've used, the term architecture. Architecture. I used to be able to spell that word. I think I've done it. That's okay. Architecture, correct. Right, now architecture specifically describes how the CPU, central processing unit, how the CPU interacts with the rest of the hardware, and in particular, whoops, that's an A, the memory. So the computer's memory, the RAM and the ROM, basically, is what you think. Well, the RAM mainly. Well, the RAM and the ROM. It is actually that, yeah, of course. Right, okay. There's two main architectures that I'm going to just briefly talk to you about, and they're here. There's only really one of them probably that you'll ever come across, but I've included the other one for the sake of completeness, I suppose. I'll explain what these different things are over here. This one, first of all, is called a Harvard architecture, and I'll explain what that's named after in a minute. So the Harvard architecture basically has a central processing unit in the middle and two separate areas, one for the programs and one for the data. Okay, this sort of an architecture is used in microcontrollers, and they generally have some sort of fixed program. Okay, the program itself is held in there. The data that's being used by the program, by the devices, whatever, by the CPU, is held in the data store on this side. What this means is basically the program is fixed and is difficult to change. On the right hand side, we've got a slightly different architecture. This is called a von Neumann architecture. Lowercase v on von Neumann. Be careful. Von Neumann Neumann. I think I might have got away with it. Okay, and in a von Neumann architecture, you've still got a CPU because that's what's doing the processing, but the programs and the data are held in the same memory zone, if you like. They're held in the same space, not obviously occupying exactly the same areas in that space, but they're held in the same sort of areas in there. Now this is the basic design for a desktop PC, and it has a general purpose. The program can be changed at will. Now this kind of architecture is named after, well, let me explain what these are named after here. One thing and one person. The Harvard architecture is named after this very early computer, which was in Harvard University in America, and it's called the Harvard Mark I. I will refer to it affectionately as Harvey. And Harvey, and you can look at the diagram here, Harvey's got two things. I don't know if you can see that sort of Perspex glass box there contains a tape, and the tape, so punched paper tape, contains the program, and over here, this section over here are relays. They're electronic devices, and those relays store the data. So there's a separation between the program and the data, which is the Harvard architecture. This guy over here is called John von Neumann, and that's what the von Neumann architecture is named after. John von Neumann is credited with the design of machines of this particular type, although some would argue that Alan Turing was also pretty much influential in that as well with his Universal Turing machine. Well, that's certainly is an A-level video right there. Okay, so that's where it is. The last thing to do for folks, we'll leave microcontrollers where they are. Let's focus on the von Neumann architecture, these little fellas here. So let's focus on that just for the last bit of the video. And I just want to talk to you about the major components inside a von Neumann architecture machine. So I've drawn hopefully a fairly simplified sort of diagram of a desktop machine. You may be familiar with the way that this looks as well. I'm going to try and label this, and I'm going to use particular colours for particular bits, and I'll explain what the different colours mean after I've finished drawing them. So we'll start up here, and I'm going to go with, first of all, the grey box that's underneath there, and that is the CPU. Okay, so the CPU's right there. Next door to the CPU, this green bars, that's the RAM, the random access memory in a normal computer system in a in a von Neumann architecture machine. We've also got here, which I've shown separately but is often contained in the same sort of box area, is some sort of power supply. I'm writing that in a slightly different colour. Also, you've got some read-only memory, which is the BIOS, or the basic input-output system, and a form of very tiny, and if you ever open a computer system you'll see one of these in there, that's a battery. Okay, and the battery is designed to just maintain the contents of the configuration settings for this the motherboard, which is this bit here, which I haven't labelled but I will do now. So this bit here, oops, that's in blue, I meant to do it in white. This bit here is called the motherboard. You can get daughter boards as well, all feminine, don't know why that is. Right, okay, you've also, where am I? I'm here, I'm carrying on round. Now you get a choice. This device is an SSD, or a solid state drive. Be careful, not solid state disk, because unlike a hard disk drive, which is this one here, HDD, it doesn't have a moving platter, a disk in a sense. So that's a hard disk drive there. Or just here we've got an optical drive, a CD or a DVD. And here we have some sort of connections. So external connections, generally to connect these external devices, and these are called SATA connections, serial ATA connections. Also, next door to the SATA ports, we've got some expansion ports there for adding expansion cards. And here, okay, again in a slightly different colour, we've got connections to peripheral devices. Peripheral means around the outside, and there's two types of peripheral device which you will probably be familiar with. They are output devices like monitors, printers and so on, and input devices just there. Now, one more thing which I haven't labelled up where is this sort of wheel looking device there, which is actually a fan. The fan is designed to keep the CPU cool. Okay, I've used three colours to represent these, and I'll explain what these colours are, but I'm not going to write that down, but I'd probably like you to write that down in your notes. The purple stuff is the vital things for a computer to operate. So you've got basically things like the motherboard, the CPU, the RAM, the BIOS, the SSDs, some sort of secondary storage device, a mass storage device that you can plug into it, you can put things in, a removable device, an offline device, connections to peripheral devices there. The green bits are the devices outside the computer, the peripheral devices in the outside world, on the edges if you like. And the blue things I like to refer to as ancillary devices, so they're used to make the computer operate but aren't necessarily required to do processing in any way. So we've got the power supply, the battery and the fan. There's a lot of information there. That's a pretty long video, but hopefully it's been fairly well broken down. Let's just see if we can, if we've answered the question, which was like 20 minutes ago, where can automatic or digital computers be found? Digital computer systems are more likely to be found inside other devices than on your desk in your office, school or home. Thank you.